Hi students, let's look at this question here, which is taken from the A-level paper 2012, paper 1, question 8, okay? So the curve C has this equation, is given that C has only one turning point, show that y, this differential equation here holds true, okay? Just show that the first derivative is this. So I think the first thing is to understand that you need to differentiate it once because this is the first derivative. So show that, so x minus y, x plus y square, just differentiate with respect to x. Okay, so this will be 1 minus dy dx. Then for this second one, just use chain rule, just differentiate outer layer as per normal, then inner layer here. So this case there will be 2 x plus y 1. So using the power rule, then after which differentiate x will be 1 plus dy dx. I think that's about it, right? Okay, so now we need to make dy dx a subject, right? Are we able to make dy the subject? Seems like it. Do we? Okay, I'm just gonna do it slowly. So this case here, 2x plus y plus 2x plus y dy dx. This is 1 minus dy dx. So we just make dy dx a subject. So I'll move it to the other side. Dy dx plus dy dx. Okay. So essentially just move this to the other side here. Then this one bring it over to the other side. Then make dy dx a subject by factorizing it out. And we get 2x plus y plus 1. 4 minus 2x minus 2y. Okay. Then dy dx. 1 minus 2x minus 2y. 1 plus 2x plus 2y. That it. Oh, we need a 1 there. Okay. We need the 1 in front of the dy dx. I think shouldn't be an issue there because I think what we need is the 1. But the denominator, I've already settled it. So in other words, we need to do some form of like long division if we want to proceed from here. Shouldn't be an issue because what can see, okay, what you can do is actually, if you want to reverse engineer it, you just combine these two as a single fraction. You'll be able to see it, okay? But what I can see here is actually what I need is to factorize out 1. So minus 2x minus 2y. I just add a 0 pair here. Okay, because I need to separate out the negative out. Okay, so what I'm saying is this one, this is what I need, is a negative of the denominator. Then once I've done that, there will be 2 minus 2x plus 2y plus 1 over 1 plus 2x plus 2y. Then you just make it a single fraction. That'll be 2 plus, is it 2x? 2x plus 2y plus 1 minus 2x plus 2y plus 1 over 2x plus 2y plus 1. That will be our dy dx. There'll be a 1 there. Okay. This will be 1. So if this is 1, then what we get is 1 plus dy dx. Okay, this is it. That's how we do this question here proficiently. Let's look at the subsequent part 2. So the subsequent part is hence or otherwise show that the second derivative belongs looks like this. Okay, so we could see that there's a 3 here. So I could just differentiate it straight, but I think the concern is always this, the one inside here. The one in it. Alright, so we try and see, is there a way for us to replace it? I think we can replace it later. Okay, we can replace it later. So from here, what I'm going to do is I'm just going to differentiate it straight. Hence, so differentiate 1 with respect to x. There will be 0 plus d square y dx square. Then we'll just do the chain rule. So the outer layer will be minus plus 2y square. Inner layer will be 2 plus 2 dy dx. Okay. So sorry, okay, I think I shouldn't skip step there. So say this is not my 1. My one is this case here. Okay. So then what we get is differentiate one. That will be 0 plus d square y dx square minus 2 2x plus 2y plus 1 negative 2 2 plus 2 dy dx. Okay, then what I do, just factorize the 2 out, and this is d square y dx square. Just see what we'll get. 2 factorize the 2 out, this will be 2 2x plus 2y plus 1 square. This is 1 plus dy dx. Okay, the amazing thing is that this is my dy dx. All right, this is actually my dy dx. I need, this is 1, so 1 plus dy dx, so I can just substitute the other one. So I just rearrange this nicely. D square y dx square 2 4, in this case there will be okay. This one from 1 is actually dy dx plus 1. So this case there, what we get is d square y dx square. It's quite interesting question though. 1 plus dy dx square. So we get power 3. Okay. So that's how I do this question proficiently. If you've pretty okay. I think for the third part should be quite okay. You want turning point, meaning to say dy dx is 0, right? It's a max or min, and there's only 2 marks. I think you don't really need to use the first part. Part 3. Okay. A stationary value, stationary point, you will know that dy dx is actually equal to 0. Okay. So this will imply that d square y dx square is equals to minus 1 by plus 0 cube minus 1, which is less than 0. So hence it is turning point is second derivative test turning point is negative, so it's max. Okay, so that is how you do this question here proficiently. If you have any questions at all, please let us know, and I'll see you in the next question.